Have you ever heard someone say, "It's so hot out here, I could boil water to make it colder"? You might think they're pulling your leg, but there's a bit of science behind that silly statement. We all know that boiling water makes it hotter, right? That's how we make tea and cook pasta. But what if I told you that at the very top of Mount Everest, boiling water wouldn't even make a good cup of tea? Here's the thing about boiling, it's all about pressure. When we talk about boiling, we're really talking about the point at which a liquid turns into a gas. This transformation is heavily influenced by the surrounding pressure. Down here at sea level, the air is pushing down on us and everything around us. That's air pressure. It's the weight of the air above us in the atmosphere. This pressure is what keeps the boiling point of water at a specific temperature. Water needs a lot of heat energy to overcome that pressure and transform into steam. This is why we need to heat water to a high temperature to make it boil. The energy helps the water molecules break free from the liquid state and become gas. That temperature, 212 degrees Fahrenheit or 100 degrees Celsius, this is the boiling point of water at sea level, where the atmospheric pressure is standard. But as we go higher, like way up in the mountains, the air gets thinner. The atmospheric pressure decreases because there's less air above us. Less air means less pressure pushing down on us. This lower pressure affects the boiling point of water, making it boil at a lower temperature. And guess what? That means water doesn't need as much heat energy to boil. So at higher altitudes, you can see water boiling at temperatures much lower than 212 degrees Fahrenheit. This fascinating phenomenon is a direct result of the reduced atmospheric pressure. Let's take a trip to the top of Mount Everest, the highest point on Earth, standing at a staggering 29,032 feet above sea level. It's a place where the air is thin and the conditions are extreme. Up there, the air pressure is much lower. So low, in fact, that water boils at around 160 degrees Fahrenheit or 70 degrees Celsius. That's a big difference. At sea level, water boils at 212 degrees Fahrenheit or 100 degrees Celsius. Now imagine trying to make a cup of tea with water boiling at that temperature. The lower boiling point means the water isn't as hot as it would be at lower altitudes. It would be lukewarm at best. This can be quite a challenge for climbers who rely on hot beverages to stay warm and hydrated. The tea leaves wouldn't steep properly and you'd be left with a pretty sad beverage. Not exactly the comforting cup of tea you'd hope for after a grueling climb. So how does this relate to making water colder by boiling it? It might sound counterintuitive at first, but there's a fascinating science behind it. Well, when water boils at a lower temperature, it also cools down faster. This is because the boiling point of water decreases as the altitude increases. Think about it, if you have a pot of water that just finished boiling on Mount Everest, where the atmospheric pressure is much lower, and a pot that just finished boiling at sea level, where the atmospheric pressure is higher, the one from Mount Everest will cool down to room temperature much quicker. It's all relative. The lower boiling point means the water doesn't retain as much heat energy. While the boiling water on Everest is still hot, it's not as hot as boiling water at sea level. This is due to the reduced atmospheric pressure at higher altitudes. At sea level, water boils at 100 degrees Celsius, but on Mount Everest, it boils at around 70 degrees Celsius. This significant difference affects how quickly the water cools, and that lower starting point means it cools down faster, losing heat more rapidly to the surrounding environment, making it feel colder in comparison. This phenomenon is a great example of how altitude and atmospheric pressure can influence everyday processes. So the next time someone tells you they're going to boil water to make it colder, you can impress them with your knowledge of thermodynamics and altitude effects. You'll know they're not as crazy as they sound. It's all about understanding the science behind it.